This is the periodic table of elements game. These are the pictures of the first 30 elements of the periodic table. Atomic number is present, but their name is absent. So with the given diagrams, you can be able to identify what elements it is. So when you roll a dice and you get a certain number, you pick that number out and then you fix to place where it's supposed to be.
This is a crane that is used for bringing up blocks to a high-rise building, like skyscrapers and story buildings. This is the sensor. This is a rubber band connecting it to the motion sensor, that anytime this is moving up, this should go up. And in order to program this bot, it has to be connected to your system through Bluetooth using the Widu 2.0 app. Now, for you to bring it up, you need to use this code. I want it to use 5 seconds. Now, it goes up for 5 seconds. Now, I want it to go down for an additional 5 seconds. It goes down for 5 seconds. Now, in order for this to carry any blocks, from down here, the blocks need to be put inside here. And after they are put inside, this is programmed to take it up. And when it's reached a certain destination, it then gets removed from the top of the building, and it gets removed at the top of the building, and it comes down to get more bricks if needed. This is the elevator that is used to carry people up the crane. The first thing for you to do is program it to which number you want. I'm going to program mine to 7. I'm going to do it again. Now, for it to get down, you need a 7. That is how the crane's elevator works.
Today, we are going to be teaching keep counting by 5. But we are going to reinforce it using a skill in computer. These are going to act as my primary 2 class kids. I have just stacked the cups the way I want to see it stacked. We're going to get them grouped. So each group maybe will have 2 people. One is the programmer, one is the person who is going to be the robot. I'm going to tell you about 4 new vocabulary you're going to be expecting today. The first one is algorithm, and for algorithm, it's just step-by-step instruction to carry out a task. And then the next one is bug. Bug is a fault in anything that you're doing. That's a bug. And today, the programmer would be the one to raise their hands if they see a bug when the robot is going to be carrying out the instruction. And debugging is removing that bug, that problem in the algorithm. If there's a problem in the algorithm, the programmer will be the one to help us first of all identify the bug and then think of how to get it rectified. Then a program is an algorithm that has been written to be able to be carried out by maybe a machine or a process or by anything. So today one of the students will have the program loaded on him or her, and then she's going to act as a robot, and then she's going to help stack the cups just like I stacked it. The cups are numbered, so they will be able to stack them and place them how they should be. They're going to help us write a program, an algorithm that the robot would act on. Okay, so what I expect to see on the paper I'm going to give you is just these arrows. For the purpose of this algorithm we're going to write, when you see this arrow, it means step forward. After the first line, you're going to now be placing it in between, just like I placed it. Your step forward will now be not going to enter into this, but it's going to move on top of another one. If I have all the cup sets here, when I do this, it means pick up. I pick one up. And then for the first base, I'll have it just drop it. But it means I will step forward. That means I pick it up, I step forward, and I drop it. The next line will be pick it up again, step forward, and then drop it. Okay, so I want just the codes. I know that some of you might begin to number it. The robot does not understand numbers. It only understands codes. And so these are the codes that we're going to be using today. And then if there's a bug, then the programmer will raise his hand and then we're able to debug the whole algorithm. Okay, so we can see all the movement has been represented in codes. So the robot is going to start picking the cups and then layering them so that we can see based on the code. We didn't start from here. There's a bug. So we're debugging by removing this. Even though it stops here, the next instruction says pick it up and drop here. What we just did was a simple program, and what the robot understands is programs and codes, and then we use the arrow to act as our code this time around, and we have been able to stack the cups. We're going to be making hand bracelets for each of the students in the class, and the underlying innovate is to teach the kids what we mean by binary codes. But everyone is going to write out their names and then make a bracelet using their names as the bracelets. So we have the ASCII codes. If you look here, you will see A corresponding to 0110, but we're going to just consider just the 4 digits. So based on your name, Favor, what do we have? So right now, where we see F, and F is 0110. So we start. This will act as our ones, and then this color is our zeros. So for the first one, which is Favor, Favor is 0110 for F. So we have 0, 1, another 1, and then 0. F. Then for A is what?
0, 0, 1.
So we're going to have it neatly placed on her hand. Please bring your hand. So we have the bracelet on her hand depicting her name, and then with a reference from the American Standard Code Information Interchange. What we're going to be doing today in physical education, we're going to link it up with coding. We're going to be looking at basic things we're going to be doing. We're going to clap our hands. I said we're going to clap our hands, throw the bean ball, touch our nails, and put our hands on our waist and shake. We're going to also have the posing. After doing all this, you can pose. So the first thing we're going to do is do what? We clap our hands. So I want us to do 1, then we do 2, and then we now do 3. We now do 2 again. We now do 3. We do 2 again, and then do 3 before we do 4. And we continue to do 4 endlessly until I say stop. Stop! Is there anything you noticed? What is happening here? This is happening 3 good times. This is happening 3 times. And this is happening what? Forever. Until I say what? Stop. So there's a run button. We have the clap. We have the touch the nail, throw the ball. Then we have touch a nail, throw the ball, touch a nail, throw the ball. Strike a pose, strike a pose, strike a pose, strike a pose. This is a PhD class. Well, we just used it to run a program. I'm introducing you to what is called what? A loop. We see this happening 2, 3, 2, 3. I don't need to write it. What if I write 1? Okay, I put the run button, run, and then I put touch your nail, which is 2, and then I put 3, isn't it? And then I put a circle and I write 3 times. And then I put an arrow because it tells you it's moving to this. And then I put here, strike a pose, which is 4, and it's going to happen forever until I say stop. So we're going to do a representation of what we just did now. This is the on button, and this is activity 2, which is touch your nail, and then throw the ball, and then strike a pose.
So this is an excellent teaching aid for elementary science in primary schools. This is the diagram of the alimentary canal. So this is made in form of an apron. It's a puzzle and it's a good teaching aid. You can remove all the pieces and then ask the students to fix it in the right position. We have everything mapped out with their names on it. So this will not just help the children understand the topic, but will give them a physical view of what it's like in their body.